All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.8 in Algebra 2, which is the last section in Chapter 8. This is video 1, and we are solving radical equations. So recall that if there's a single x, or variable, but usually x, in an expression, we can use SADMEP to solve. However, sometimes when we solve equations involving even roots, we end up with answers that do not actually work mathematically. Essentially, this comes from the idea that the output of any even root is non-negative, and we're going to talk about that in a sec, but let's walk through a quick example of what I'm talking about so it doesn't sound like utter nonsense. So as a quick example, here's 2 times the square root of x plus 3 plus 10 equals 2. We're going to go ahead and solve with SADMAP, and we're going to get 13, right? So I would do subtraction and addition first, right? I'd subtract the 10 from both sides, and I'd get this 2 times the square root of x plus 3 equals negative 8, right? Then I would do my division and multiplication, and I'd divide both sides by 2, and I'd get the square root of x plus 3 equals a negative 4. Then I'd deal with the exponent by squaring both sides, so I'd get x plus 3 equals a 16. And then I would subtract, right? I'd do the thing that's inside the original parentheses and subtract the 3, right? So I squared both sides here. I subtract the 3, and I get x is 13. And I'm like, yay, I'm awesome. But then just in case, I go back and I check. And what you're going to find is that if you plug into the original function and see if you get a true statement, 2 times the square root of 13 plus 3 plus a 10 is a 2 root 16 plus 10, which is 2 times 4 plus 10, or 18. 18 is very much not equal to 2. So I'm going to show you that there is a spot where you could make a mental leap earlier that would have made you aware that this is an issue. So pretty much right here, where I get this statement, it's possible, and arguably the step before that, depending on how quick you are at noticing this, I can spot right here that there is no solution. At this moment, I know from doing a lot of high school math for a very long time that there's no solution. And the reason I know that is I know that the output of this expression is non-negative. It has to be 0 or positive, right? Non-negative, so 0 or positive. And I look on this side and I say, wait a second, that's a negative. That's not possible. A 0 or positive output can't equal a negative 4. I'm done, there's no solution. So you can either solve the entire problem down to the 13, check it, and say, wait a second, I get a false equivalency. I get 18 equals 2, and that's not true. So there's no solution. Or there's a chance you'll be able to spot it earlier. One thing I want to caution you about, because chances are if you're sitting in my class, you're generally someone who's pretty clever at math, and you often spot shortcuts like this, and that's awesome. I don't want to discourage you from doing that. I don't think that it's important necessarily to show work if you can communicate understanding. Now, if you just jump to no solution, I would want you to communicate in some way why it's no solution. Tell me something. It can be in these like crazy sort of math hieroglyphs that I wrote. It doesn't have to be complete sentences. I don't need you to like tag it a meal or whatever you're supposed to do in your English classes. I don't care. So I don't need a paragraph about this. I just need some kind of communication. But the caution I want to give you is because you're generally a clever human, sometimes you look for shortcuts trying to outsmart a test or outsmart a problem, and you spend so much time looking for the shortcuts that you miss the simpler problems, or you snap to the wrong judgment and you think something's a shortcut when it's not. So just be mindful that, yes, there are going to be problems that have no solution and that there's a trick to them sometimes, but don't be always looking for those problems. Certainly you'll come across them. Sometimes keep them on your radar, but don't assume that every problem is that trick. All right, so let's go ahead and move forward. So the principle of powers, if a equals b and n is a positive integer, then a to the n equals b to the n. So basically, this just says that you can raise both sides of an equation to the same power, which we pretty much already know, right? So let's go ahead and solve this. And the reason that you're being asked to check your solution is because anytime you're dealing with even roots, you should check your solution for the very reason that we saw over here, which is sometimes your answer is going to look mathematically right, but then turn out to be wrong. So I'm going to go ahead and use subtraction and addition. There isn't any because everything's in the root. I look for division and multiplication, and I realize that I can divide both sides by 2, right? So I get the square root of x plus 5 equals a 4, which is legit, right? Because x plus 5 is a non-negative output, and 4 is a non-negative number. To deal with the exponent, I'm going to square both sides, which is totally why this rule was brought up, right? So I square both sides, and I'm going to get x plus 5 equals a 16. Right? And so then when I deal with what was in the parentheses, I'll subtract 5 from both sides, and I get that x is an 11. I'm going to go ahead and check my answer, right? So when I check, I'm going to check the original. So 2 times the square root of 11 plus 5 is supposed to give me an 8. That's a 2 root 16. Well, that's a 2 times a 4, and that checks out, right? So that's 2 times 4 gives me an 8. So I'm all good, and my answer is 11. Go ahead and give P3 a try. There is no subtraction or addition. There is division or multiplication. I can divide both sides by 3. Notice that, again, you can't divide into the root, right? It's the coefficient in front of the root. The root's sort of like this lockbox. So I have a root of 2x minus 1 equals a 2. And again, that's legit. You can always kind of do that logic check. This is a positive or 0 output, and 2 is a positive number, so you're all good. When I deal with the exponent, I'm going to square both sides, right? So I'm going to get a 2x minus 1 equals a 4. When I deal with the stuff that was, it's a p. When I deal with the stuff that was inside the root, I get 2x equals 5. X equals 5 halves, right? And that seems to be my answer. I'm going to go ahead and check. So I have a 3. When I do the square root of 2 times 5 halves, minus a 1, and the question is, does it equal 6, right? Well, that's a 3 times the square root of, this will be a 5 minus 1, and the question again is it a 6? Well, that's a 3 times root 4, which is definitely a 3 times 2, so yeah, we're good, right? 3 times 2 is a 6. All right. Okay, so let's go ahead and solve this one, right? So right away, now this time I do have more than one x, so I can't just go ahead and use SADMAP, but I notice that I am allowed to raise entire sides of the equation to a power, so I'm going to raise this side to the third and this side to the third. And what's going to happen as a result doing that is I'm going to get an x minus 5 on this side, and I'm going to get a 7 minus x on this side. I'm going to move all my x's to one side, so I'll add the x over here, and I'll move the 5 to the other side. I'm going to get a 2x equals 12, so x should be 6. Right? And we're going to double check that our solution works. So the cube root of 6 minus 5, is that equal to the cube root of 7 minus 6? Well, that's the cube root of 1 equals the cube root of 1, and yeah, that's true. 1 equals 1. All right, go ahead and solve this one. So again, same situation. You have a square root on both sides, right? So what we're going to do is we're going to square both sides, right? So I'm going to get an x plus 2 equals a 5 minus 2x, right? And what I'm going to do from here, and what you'll see in some of my previous work, is there have been times in the past that I've told students that they have to write this in an absolute value because it's because we don't know if x is positive or negative, right? And so that's the tricky, right? Because we don't know if x is positive or negative, and we need this thing to have a positive output. But here's my logical argument. So I've redecided, like after spending years and years forcing students to write this in an absolute value, I've thought it over and decided a logical reason that you don't have to do that. So even if in some of my older notes you see that I did, there's a reason you don't have to, and the reason is that if, let's say that I get x is negative 7, I don't know. Negative 7 plus 2 is going to give me a domain restriction when I plug in, right? So by default, I don't have to worry about putting an absolute value here, because if I do get an answer that gives me a problematic value, when I plug back in to check my solution, I'm going to catch that it's an error. So I don't have to worry about the absolute value, because essentially anything that would make x plus 2 negative, right, would not be in the domain of the original question. And the same thing, anything that would make 5 minus 2x negative won't be in the domain of the original question. So if you look back at some of my much older notes, you'll see that I forced people to write these in absolute values and made your life actually significantly harder. But logically, you don't have to worry about that, right? So essentially, what's going to happen is if we do get an answer, because we didn't write the absolute value, if we get an answer where this doesn't work out the way we want it to, where I get x is, let's say, negative 7, I'm going to catch it when I check the solution, because I'm going to see that there's a domain issue. I can't plug a negative 7 into an x plus 2 inside a root. So anyway, when we go to solve, I'm going to go ahead and add the 2x over and get a 3x. I'm going to subtract the 2 over and get a 3. So I get x is 1. And when I go to check my answer, I'm going to get the square root of 1 plus 2. And the question is, does that equal a 5 minus 2? Sure enough, I get root 3 equals root 3, and that checks out, and my answer is 1. All right, that's it for the first video.